Okay, so for this lesson, we are going to talk about operations with radical expressions. So we're going operations, meaning add, subtract, multiply. We're not going to really be dividing in this particular situation for this lesson. So mostly just addition, subtraction, and multiplication with radical expressions, meaning with square roots in them or with variables with exponents, etc. So first, we just want to make sure we know the difference between an expression and an equation. Remember that an expression can be simplified, which means that it has x can be any value. So x could be anything. There's no limit to what x can be. And an equation has an equal sign. So equation is solved, and x has a particular value or a specific value. So the difference between one is solved, one is simplified, and x has a particular value. So if we'll look real quick at these next few, I said list the steps for simplifying. Now we're going to practice first with some that have variables and not radicals just yet, so that we can review our skills with solving. So we have one that's addition, one that's subtraction, and one that's multiplication. So first, the steps. So for the first one, we would combine like terms, and you often see me write CLT. Okay, so for the first one, we would just combine like terms when we're adding. When we're subtracting, first we need to distribute the -1. And then we would combine like terms, or CLT, combine like terms. And finally, when we're multiplying, so hopefully you see the difference between addition, subtraction, and multiplying. When we're multiplying, we would distribute the 3x and the -2, and I call that double distribute. Okay, and then we would combine like terms. So those are the steps for those three different operations. So now watch as I do them. So we have 3x plus 4x, those are like terms, which makes 7x minus 1. Then I'm going to distribute the 1 for the next problem. So I have -x minus 3. And then for when I'm multiplying, you always see me start with 4 lines, and that helps me remember that I need to multiply 4 times. So 3x times 4x is 12x squared. 3x, -2x, I'm sorry, -8x, and -2. So 12x squared minus 5x minus 2. Okay, so for these 3 problems we just did, they were a variable. So now let's try that same 3 problems with a radical. So here we go. Okay, so first, they are like terms, so I know that I can combine them. So I have 3 square roots of 2 and 4 square roots of 2, which makes 7 square roots of 2. Then I'm going to distribute the -1, just like we did before. So negative square roots of 2 minus 3. So that one, very similar to the one with x. Next one, very similar to the one with x. Okay, now the next one's still going to be pretty similar, just a little bit of a difference. Okay, so I'm still going to multiply. How many times do we multiply? 4 times. Remember we call this distrib or double distribute. So 3 times 4 is 12, and square root of 2 times square root of 2 is 2. And if you don't understand that, really think about it. So like the square root of 5 times the square root of 5 is 5. Square root of 7 times the square root of 7 is 7. Any square root times itself is the number inside. So I have 12 times 2 plus 3 square roots of 2 minus 8 square roots of 2 minus 2. And then I combine like terms and get 22 minus 5 root 2. Okay, now the next problem is not like terms, because I have square root of 3 and square root of 2, so not like terms. So only ones I can combine in this time are the -3 and the 1. So maybe pause that and look at it again. Okay, next thing, also not like terms. So see where I got that answer. Can't really combine anything else other than the -2 and the -1. Those are the only thing that are like terms. Nothing else is a like term. However, I can multiply anything. Doesn't matter if it's like terms or not. I can always multiply. So watch as I multiply this one. And you might want to take a little pause here in a second and really look at this at these problems. So 12 square roots of 12 plus 3 square roots of 6 minus 8 square roots of 2 minus 2. And then I'm going to simplify 12. 2 gets to leave the party. 3 had to stay. 24 square roots of 3 plus 3 square roots of 6 minus 8 square roots of 2 minus 2. No like terms. So I cannot combine any of them. Okay, so for this last little set, first they need to be simplified, then they need to be combined. So remember, when we're simplifying, we are taking out of the house. Okay, so we want to find pairs that can leave the house. So the first one, no one can leave the house, but they are like terms. So I get -4 square roots of 6 because 3 minus 4 is -1. Okay, then for the next problem, I'm going to break it down to 9 and 6. 3, 3, 3, 2. Okay, so right there I know that one set of 3's can leave. So first I have the 3 from the original problem, the coefficient. That's the coefficient 3. Then I have the 3 that got to leave the party. Then I have the square root of 6 that had to stay in the party. Okay, so really make sure you understand where all that came from. So in the end that makes 9 square roots of 6 minus 4 square roots of 6, which is 7. Okay, so maybe pause and then try one on your own, or just continue watching. So 8 is 2 times 2 times 2. So the 5 is the coefficient. 2's got to leave the party. 1, 2 had to stay. Plus 3 square roots of 2. 10 square roots of 2 plus 3 square roots of 2 is 13 square roots of 2. Okay, so pause again. Try the couple more. I'm not really going to talk through these. I'm just going to write the answers down. Okay, remember, anytime pause is needed. So you're looking at who can leave the party, and then multiplying who can leave the party by the coefficient. Okay, so once again, who can leave the party? Finding pairs, who can leave, leaving the things that can't leave, and then finding like terms. So in this particular problem, we have two things that have square root of 5. So I know that I can combine some like terms in the end. Okay, and lastly, square root of 45. Break it down. Square root of 54. Break it down. And then combine like terms. Okay, and then in this particular case, the square root of 5 and the square root of 6 are not like terms, so there's nothing else I can do at that point. Okay, where is the way to check this with your calculator? And the way you do that is you type the question and you hit enter. So type exact question, whatever the question may be, and hit enter. Then you type the answer and hit enter. Guess what? Those two solutions should be the same. Now, a lot of times there'll be some weird decimal, and that's totally fine. They just should match. So if you type the question, hit enter, type the answer, hit enter, they should match. Okay? So I hope that helps you out a little bit. We'll be trying the practice tomorrow in class and answering questions. So have a great day, and I will see you all soon.